So, how do you do a cross product, and what is a cross product anyway? Well, before, if you remember, we did dot products. And an example of a dot product is when you take force and you do the dot product of force and displacement to find the work. The idea is that with a dot product, the parallel parts are what matter. So here in this its list form is force times displacement times cosine theta. So this is what it looks like written: force dot displacement. And that's a dot product. The maximum result is when the maximum are parallel, or the components are parallel. There are some situations where when it's not parallel but it's perpendicular that you get the maximum result. This T, this funny looking T, represents torque. Torque is kind of like the rotational version of force. You can get the maximum torque by taking cross product of the radius and the force. This is what the symbol, the way it's written. Radius, x, meaning the cross product, force. So, the idea is, say you want to open the door. Well, it's hard to open a door if the knob is close to the hinge, right? So the longer the radius, the easier it is to open the door. So that when the doorknob is on the opposite side of the door, opposite from the hinges, then it's easier to open the door. So a bigger radius is a easier, bigger torque. The force you apply to pull the door open or to push it open will be perpendicular to the radius. If you try opening the door with a force that's parallel to the radius of the door, I know you're thinking, radius of a door, how's that possible? But it's actually it's the length of the door, so it's kind of hard to imagine where the hinges are the center of the circle, and so the door swings around. If it could continue to swing all the way around, then the radius of that circle made is the length of the door, the length of the door. So that's a cross product. Okay. Let's do one. Let's find the cross product of a cross product of vector B. Okay. So first we'll need to put the categories in. The three different dimensions are I hat, j hat, and k hat. And those are just the directions using vectors. It's the same thing as x, y, and z. You could put the categories as x, y, and z. However, since we're using vectors, x, y, and z coordinates, spatial coordinates, those are dots, not lines, not arrows. So I hat, j hat, the lines on top, we call them hats. So I hat, j hat, k hat. All right, let's put them down. I, j, and k. Now, looking at all the components of each vector A will have an component, a y component, and a z component. Vector b will have x component, a y component, and a z component. We're going to multiply each one, and when we do that, you'll notice that we're crossing to multiply them. That could be another reason why it's called the product, is you do this crossing to multiply. Okay. So, really the formula for all is, in the I direction you look at j and k. In the j direction you look at I and k. In the k direction you look at I and j. So and beeping you're hearing in the background means that the laundry is done. Plus az bx ax bz busy plus ax I minus ay bx that's okay. And that's the formula you use to find the cross product. Your answer will come out in some number and some number j hat plus some number k hat. And you can use the Pythagorean theorem to find the ultimate line that is made by these. That's it.